there's just one change I've made, two changes that I've made to what we had in the previous video. The first change is that we're not going to be using make files directly. We're going to be using CMake. So we'll need to create a CMake list.txt file that is going to sort of like include all the source files we want to compile, and also specifications of what version of C we are using, and also the minimum version of CMake that we are going to be using to compile or build our project. And of course, there is one thing that I've added here for the structures node and the structures state because we have these forward declarations. If we do not specify the types here, where here as we are sort of like defining or implementing these structures or giving definitions to these structures that we have here, we're going to have problems later on. So make sure that you add this node here and also this state that we have here, because these are the types that we've defined here, right? And recall that we have these forward definitions here because the two structures, one for the states and one for the transitions, depend on each other, right? So we'll have a problem if we don't have these forward definitions, and also if we do not specify, give the specifications here, node and a state t for the transitions and for the state structure respectively. Now the very first thing that we want to do is to create a cmake.list text file that is going to automate the generation of what is known as the the make files, right? So let's do that, right? So I'm going to create it in the root of the project directory. So I'm just going to create a new file like so, and then we're going to say cmake list.txt like so, and of course the IDE helps me a little bit here. It sort of like gives me the icon to show that this is actually going to be a something that CMake is going to look for, right? So the very first thing that we want to specify here is the minimum version of CMake that is going to be required to build our project. I haven't thought about this one. So we're just going to say, the version is, let me first of all check the version of CMake I have, and maybe from that we can infer the version of the minimum version of CMake we're going to use to build this project. So let me just go CMake -- version. Probably have to like increase the height of my terminal. So I have CMake version 3.31 installed. So I'm going to say the minimum version required to build our project is going to be 3.30. I'm just going to say 3.30. Now, now that we've specified, we need to also say project, and then the name of our project is, I'm just going to say autonlib, and then the C is going to mean that this is going to be, a C project. Now we want to add the following executables. Now we want to, after compiling everything, we want to generate an executable file. Now the name of the executable file is what I'm going to specify here. So I'm just going to say autonlib like so. This is going to be the name of the executable file we're going to generate, the file that we're going to run in our terminal to to give us the program, our program. For example, if you want to print hello out to the screen, you have to execute this executable file for you to be able to print the output to the terminal, right? So we want to first of all, before we even do anything, let's first of all create the main.c file. Now I'm just going to like put it in the root. So I'm just going to say main.c like so, and then this is our entry point into the program. And then let's include the two header files that we have so far. So we are outside, we are in the source, we are in the root of our project directory. So we need to get to the header files. So to get to the header files, we need to go into the include folder and then grab the first header file. So we're going to say automaton.h like so, and then we're going to do another include, same thing. So we'll go // no, not that, forward slash like so, and then we go into the include folder, then grab the second one, which is auton memory, in case we need to use it, right? In case we need to use it, and then .h like so. Now we'll define our main function. I'm going to say main. We're not going to take in any arguments for now, so we're going to pass in void, and then this is returning an integer, so we should say return 0 at the very end. So this is what we have. This is our main file. Now let's include the other source files in our CMake list, right? So let's include the first one. So we are in the root. So remember that we are in the root. So the very first thing that I want to do is to go into the source folder, go ahead and grab automaton.c, our first source file, and then I'm going to write the second source file on the next line like so, and then we want to grab auton memory. So this is, we want to compile all of these, generate object files, link those object files, and then produce an executable autonlib from those object files that we are going to link in the very last phase of our compilation process, right? So not h, but we're going to say auton memory.c, right? So these are the only files that we have, and we should probably specify I think, yeah, this will be enough. This will be enough. So this is what we need for now. Now we have our CMake list. Now there's one thing that you have to pay particular attention to. So we are in Visual Studio Code. So CMake list is going to automate the generation of the make files. Now by default, if we don't specify the generator, if we don't specify the generator, it is going to build for Visual Studio. So if it builds for Visual Studio, I want it to build for the MINGW compiler, so that we can use the GCC compiler to like compile everything and produce the executable file. So you are going to see a different folder structure if you do not specify the generator. If you do not specify the generator to use. So that is a very, very important thing that we're supposed to do. Now we're going to isolate our build files, anything that any folder that is going to be generated during the build process. We want to isolate it from the rest of the code that we have here. So for this reason, we have to go into the build folder, right? We have to go into the build folder. This is where we're going to put everything that is going to be generated. That's where we're going to put it, right? So that is very, very important, right? Isolate whatever file, whatever folder is generated during the build process from the rest of the code. Now, to be able to specify the generator, we'll give this -g flag, and then we're going to have mingw makefiles. Now this dot here means go one directory up, and then go ahead and look for the CMake list.txt file. So this should get us to the CMake list.txt file, and it's going to read this CMake list.txt file, and everything should be good, right? Everything should be okay. Now let's run this. If we run this, you can see that the very first thing that we do here is it tries to it builds everything for us. Now if we inspect the build folder, if I go into the build folder and inspect the build folder, we should see a make file. So CMake automates the generation of the make file. So we had to do this manually on our own, but now we are doing it with CMake. So that's the difference. We would have used the make file on its own, and then would have provided all everything that we need to compile our project. But then what we're doing now is using CMake to automate the generation of the make files, right? So you can see the classics, some of these things, it adds additional things to the make file. But then some of these things you can easily recognize them, like the clean, the clean, you can recognize the clean. You can recognize the some of these things can be recognized, right? right? So now that we have this, remember that I'm doing this on a Windows machine. So if you're on a Linux, the next step you can do here to be able to produce an executable file from the make file that we have here is to just call the command make. Now this is going to look for the make file, look at the configuration, and then produce an executable from the configuration in the make file, right? But on Windows, this is not going to work. Now if I do this, you can see that bash says make command not found. Now we're very lucky that we installed the mingw toolkit. So it comes with a utility mingw 32, I believe, and then make. So this is what is going to like do the same thing as running make on a Windows on a Linux machine. Okay. Yeah. So this is what we're going to do on a Windows machine. So we're going to use mingw 32 minus make like so. So if I hit enter like so, this should build, and of course we get some errors that now this is not a big deal. So the first thing that I want to do here is, so let's first of all look at what we have here. We should normally see an executable. If everything is okay, we should see an executable that has the name autonlib that we can run, right? So that is the idea. Now let's first of all provide we have a main.c file, we have a main.c, right? We have a main.c. Let's try to print something to see if everything is okay. Now as long as you do not change the configuration in the CMake list.txt file, you do not have to like do the CMake generation again, unless if we add new files, additional files, or remove files from the CMake list, we need to like redo the whole thing. But from now henceforth, we're going to be using the ming 32 minus make command to build a new, or to generate a new executable file, right? If we add new folders, new files to the CMake list.txt file, then and only then will we regenerate the make file through CMake. So that is the idea, right? So let's try to print something here. Let's try to print something here so that we can see that something is happening here. So let's go hello world like so. Very basic program, not doing anything fancy here. We're just printing hello world to the terminal, right? So we've not added any files to the CMake, and so what we have to do is, if I hit enter like so, it still gives me this problem here. Now all the errors are enabled. If you look at this if you look at this particular error that we have here, it says undefined reference to winmain, like so, undefined reference to winmain. Normally this occurs when there is the entry point is not specified. Let me just look at our CMake. Remember, you see, that's the exact problem that we have here. The entry point is the main function. The main function is the entry point into our C program. If you look at our CMake list the text file, you can see that there is no the entry point is not there. So that is why we get this error that we are seeing here. So if I quickly change things here and say main.c, remember we have to also include the main.c because it is in the main.c file that we've implemented the main function, which is going to be the entry point into our application, right? So very, very important notion to keep in mind. So now we've added an additional file into the CMake list.txt file. So we need to like regenerate the make files and everything that has been added to our build folder, right? So for the sake of clarity and things like that, let me just delete these folders that we have here manually, so that let me just delete them manually like so. Off they go into the recycle bin, right? So I've deleted everything manually. You can see that our build folder is empty. Now we have to rerun the entire process. Now remember, I told you that if you do not specify the generator, it builds for Visual Studio. it builds for Visual Studio. So you're going to see a totally different a different structure from what we had in the build folder, right? So here I'm just going to specify. You can try it at your own time, without providing the generator. Just run CMake. Actually, let me just show you. Let me just show you so that you see what I'm talking about. That it is going to build for Visual Studio, right? If I hit enter like so, now you can, if you are reading the messages in the terminal, you can see that it says building for Visual Studio somewhere here, right? It builds for MSV, okay, MSVC, right? So if I look at the build folder, you see a totally different structure. You see a different structure here. You see these files that we have here, okay? So we have to specify the generator. We want to compile with GCC, with a GCC compiler, and work with the GCC compiler, and we don't want to build with for Visual Studio or anything like that, right? So again, I'll just manually can I maybe highlight these and sort of like delete them at the same time? Let's see if that is possible. And if I hit delete, okay, it deletes everything for me. Oh, we still have one folder we need to delete here. And if I delete that, our build folder should be nice and clean. Now let's now specify the generator and see what we get, like so. Okay, this is the command that specifies the generator. So if I hit enter like so, it takes time to do its thing, and finally it does the correct thing. Now let's look at our build folder. We see the make file. Previously, when we did not specify the generator, it was building the project for Visual Studio. So we saw a totally different structure, from what we have now. Now that we have this, it is now time to use our utility mingw32 mingw32 minus make, like so, to generate an executable file. Now I want you to look at the build folder here and see what is going to happen as I press enter, like so. So it builds 100%, and of course you get the executable file with the same name that we've specified here, autonlib. If I want to run my program, it is actually easy. What I have to do now is to say, I think we have to say, because I'm in git bash, I have to like say // autonlib, and just autonlib, like so. It is going to run the executable file, and we see the beautiful text on the terminal, hello world, right? This is how we know that everything is okay. The error has gone because we now have an entry point into our program that I've defined in the main folder. Great stuff. Now let's now test the code that we've written so far. Now before we even test the code that we've written so far, we need a way of like printing things to the terminal. Maybe if we create a state, we create a transition, we create the alphabet. We need a way of printing things to the screen. This is not going to be like permanent. I will remove it. I might delete it later on. I might delete it because what we're building is a library. So the product that we expect to have at the very end is a library. So most of these things that I'm using for testing will be probably deleted, or maybe they'll go into the tests folder. Each time I want to test a few things, I'll probably like reference what I did. And yeah, that's what we're going to do. Now for now, let's just keep everything simple, and let's write a very simple function that is going to help us print the information that I've just described to the terminal. Now let's look at, I'm going to write it in automaton.c. Now let me just close the terminal window. We'll come back to that. How do we print something? And of course here, before we even like go any further, before freeing the alphabet, we need to loop through the alphabet, because remember, every item is a pointer. So we need to free the individual items before we even free the the container or the parent that contains those pointers. So here we have to correct this particular code that we have here. So we'll have to loop through the alphabet. Let's quickly do that before we even do that. And I don't know why I forgot to do this. So for int I is equal to 0, we would have actually done size t, because we know that the counter is always positive, but well, that does not matter. So for int I is equal to 0, and then I less than automaton, let's go automaton, and then let's go alphabet, and then let's go num members, like so, and then let's go I plus plus or plus plus I, like so. And we want to go ahead and call auton free on each member, right? On each member, we want to call auton free on each member. Remember, we wrote this memory safe wrappers. I think 2 videos ago, one video I can't really remember very well. So we wrote these memory safe wrappers. So I'm going to throw in each member of the alphabet. I'm going to deallocate the memory now, right? So we're going to say automaton, and then we have to go alphabet. I believe now members, like so, and then we throw in that lovely I there, right? Now this is going to handle, this is going to free all the memory, all the symbols, all the memory we allocated to store, each symbol, right? And then at the very end, we want to free, the pointer to the alphabet. No, we want to free the members. We want to free the members, like so. So this is going to free, because members is what contains, the individual symbols which are, which we are pointing to. And so if we free members, if we free all the symbols, the next thing we should be able to do, the next thing we're going to do is to free the members. Okay, if we free the members, well, let's free the alphabet. So that's the next thing that we want to do. Again, we're going to call auton free, like so, memory safe wrapper, and then we're going to say automaton, like so. And let's free the alphabet, because the alphabet is also a pointer. If you look at the way we defined our structure, does this even make sense, right? Well, if it's not correct, this code that we have here is going to seg fault. It's going to give us a segmentation fault, and we will know that we're trying to free memory that we did not allocate, or we are trying to access memory that we did not allocate. So that is what the segmentation fault generally means, right? We'll see everything. Now let's now implement the function that is going to help us, print, a few details about the automaton to the terminal. Now we're just interested in printing in printing to the terminal. We're not really returning anything to the returning anything, because there's no point. So I'm just going to, the return type is going to be void in this particular case. And I'll let this be a public function. So I'm just going to say auton print automaton, like so. That makes sense. Now let's grab, we want to, get a pointer to the automaton. And then I'm just going to call it the full thing automaton, like so. What would have just called, we maybe named it auth, just to keep the name short and all that, but then doesn't matter. So we have that. Now, what do we want to do? I want to print out basic information about the automaton, right? Now, I want to print out the states. I want to print out the individual states, probably the symbols, the individual symbols, right? Things like the counts, are they properly initialized and things like that. So that is what I want to do now. So let's loop through all the let's loop through the states array, and let's print the representation of each state. Now, of course, the transition node is going to point to now by default, and the way we're going to sort of like handle this, or maybe point it to something useful, or to point it to a transition, is that we're going to later on implement a method, the method add transition. So that is what is going to modify the pointer that is pointing to now for the transitions, now, because we don't have that method. So we're going to modify, that pointer, the value of that pointer, or what we're going to point it to a valid, transition node via the add transition method. So we'll do it later on, maybe a few videos from now, I don't know. So it could be in the next video, a few videos from now. So let's just, that's just a little digression of what to expect. So we have for int I is equal to 0, and we want to loop through. Well, do I have maybe something like a snippet I can quickly look at? Maybe I don't know if I have snippets here. Well, let's just do automaton, like so, and then let's I think num states. Okay, num states, because we are looping through the states, right? We want to know the total number of states that we have here. Now I plus plus or plus plus I. Yeah, so we have that. So we know how many states we have. We are now looping through the states. Now we just want to say a basic printf, and I think I think we should, throw in that percentage s, because, the representation of every state is a string. And so we have to throw in that percentage s for it to work. Okay. Okay, maybe let me just add the text state like so, and let's throw in that new line to make, things, readable. Because if we forget the new line, things are not going to be readable. And okay, let's go automaton, let's go states, let's go I, like so. That makes sense. Right. So let's do the same thing, but this time for the alphabet. That is what I want to print, just the alphabet and the states, because this is where we, this is like the critical section. These are the two critical sections that we have. And that we must, first of all, make sure that everything is okay before we even do anything, before we even, proceed or anything like that. Now, instead of now I want to loop through the alphabet, right? I want to loop through the alphabet. So I'm just going to go alphabet. I think we have to go num members, right? That is correct. Instead of printing the state, and then here I'm just going to say symbol, like so. Hopefully this is going to work. Percentage s, because yeah, every symbol is also a string. Makes sense. Now, instead of like printing the state representation, this time I want to go alphabet, I want to go members, then I want to go I. That makes sense, right? Yes, this makes sense. Now let's prototype this function in the header file to make it publicly available in the main file, right? Let's prototype this function there. So I'll delete this, because the goal is to be able to, maybe from the automaton that we're given, we must be able to generate something like a dot file or like a JSON file that we can give to maybe some dot file. We can feed it into to graphics, for example. Then it can generate the graph for the automaton that we've constructed. So that is what we're going to be able. That is what we want to do. That is what we want to achieve. So this print is like really, not that useful, right? The goal is to produce JSON files, dot files that the user, can later, maybe sort of like integrate other tools or things like that to generate the graphical representation or things like that. So that is what we want to do. But for now, let's keep things simple. Let me just copy this, prototype it, make it publicly available, and yeah, let's see, and we'll take everything for SPN. Right, so what is the header file? That is the header file. So let me just throw it here. Doesn't matter where you put it. You can put it in the at the beginning, at the end, in the middle, wherever you want to put it. It's going to be publicly available, right? Wherever you include the header file, that is. Okay, let's now see how we can print. Let's first of all have. Okay. Let's first of all have. Let's create our very first automaton and see what we're going to get. The approach I'm going to take is this, right? I want to try out a few methods here. I want to try at least most of the methods that I have to be confident that what we did is actually correct. And this is the point that, things might maybe change, because if we have errors, definitely we have to fix those errors. And those errors imply that something is wrong in the structure, so we might have to like make minor changes or major changes for the code to work. So that is what we expect. We expect a lot of errors. Like I said, we're making a lot of mistakes. We'll be correcting those mistakes by reading the errors in the terminal. No, that is the beauty of what we are doing now, right? So I'm just going to say automaton. Now, if you've noticed, I just like, giving my variables meaningful names. I don't like to shorten them. I want to keep them meaningful. So I just want them to be, even if they are long, but not very long again, even if they are long, as long as they have, meaning, and their meaning is related to what we're doing. All right. So that is how I name my variables. So it's something that you should consider. So the very first thing that we need to do is to initialize this automaton, right? Initialize this automaton. So we're going to call auton, I think, init automaton, the second function here. Now, what do we need? We need to pass in the number of states. Now, I just want 2 states for now. And then the size of the alphabet is 2. right? But then I might have to rethink the architecture here, because if I initialize the alphabet separately, the user might maybe pass in a different length for the alphabet, and that might cause problem later on. So we need to sort of like rethink the architecture, but not in this video. Probably in the next video, or in the upcoming videos, we'll sort of like change a few things to like keep our initialization consistent. So we'll try to like rethink the architecture and things like that. So in the very end, what do we want to do? Now let's terminate that with a semicolon to get rid of that error. And the very end, I want to print my automaton. I think it's auton print. That's what I called it. Now let's just throw in that automaton here. The very end. Before we even print, let's do a few gymnastics. Let's first of all define the states. Now I've said that here I want to store two states, right? I want to store two states. How do I do that? Well, the very first thing that I want to do is I'm not going to use any for loop, any of those fancy techniques to sort of like do things in one go and things like that. I'm just going to like do everything manually to wire everything up manually. So we can technically use a for loop here. We can also use a while loop or things like that, but then that's not the point. The point is to see if our structures are working, right? So two states, meaning we will have indices from 0 to 1, right? Makes sense. States, and then I'm going to go init state, auto init state, I think. Remember that all the public functions are prefixed with what are we supposed to pass in here? I think we're supposed to pass in the representation, so I'm just going to say Q0, like so. We're supposed to is starting state, or for now I'll just say 1, and is ending state, I'll just say 1. So it is a starting state, it is also an accepting state. Makes sense. I'm just going to copy this. Now, when you're copying and pasting things, you have to be really careful, because that's one source of that's a potential source of errors. Copy and paste, but then we're just copying and pasting one line. Nothing strange can really happen here, and yeah, it's easy to see that we've done something wrong and that we probably not doing the correct thing, something like that. So here it's not a problem. So Q1, then here I'm just going to say Q00. Now don't worry if the initialization here is maybe a bit weird or something like that. The point is to correctly allocate memory and correctly deallocate memory, because that's all we've done in the previous videos, I think, right? Now there's one thing that we for the symbols of the alphabet, we have to allocate memory to store each symbol. Now I'm going to I think let's first of all include, I think it's the string. Let's include the string class. I think it's std string, or is it string.h? Is it string.h? What is it called? String? Is it string? Yeah, it strings. It's string.h, right? String.h, like so. Now I'm going to use now remember that we have two symbols, right? So probably have to like move a little bit faster. Otherwise the video is going to be very long, and I don't want that. So alphabet, let's go members. I think members, is it alphabet? Oh, members, okay. And then 0 again. Remember, I'm going to do this manually. 0, and I'm just going to say string. I think it's string duplication. It means duplication, and I'm going to throw in the A here, the first symbol that we want to store. If you do not do this, if you use something like string copy, you're going to get a segmentation fault, right? You're going to get a segmentation fault, and yeah, we don't want that to happen. Okay, fingers crossed. Is this going to work? Now let me ask you a question. Do we need to like again regenerate the make file, or it's okay, we can just go ahead and compile from the make file that we already have? Or you guessed it right, we have not made any changes to the CMake list.txt file, right? So we're just supposed to like compile from the make file that we have. We've not added any files. We've just, modified the contents of, the files that we've added into the CMake list. Now, all in all, it's going to detect the changes. Probably we might use a different build system in later videos. Maybe we might use Ninja or something like that, because yeah, it supports that also, Ninja. That's a different build system again. Okay, great job. So yeah, let me just look at what we have here. States, good. We also have the symbols, and now fingers crossed, is this going to work? Let me just I think it's view terminal. Yeah, great job. So let's clear, like so, let's clear the terminal, and let's rerun our CMake. Hopefully we get no errors. Okay, 25%, 50, 100%, no errors. That's great information. Now, are we going to get a segmentation fault? Are we going to get a segmentation fault? Let's see. If this works, then it's going to mean a lot for us. Up, and remember, the first symbol is, it says the first symbol is no, and this makes sense because what we are saying here is 0, 0. We've not updated the, remember, like I said, copy and paste is one source of errors, right? Copy and paste is one source of errors. You have to avoid, you have to minimize, the number of times you're copying and pasting things. This is what has caused the problem here. Now let me just save that, and let's see what we get. Let's see what we get. And it makes sense. It makes sense, right? It makes sense. And one thing that we have to do in the later videos is also like define macros. If I sort of like pass in something that is no, I need to be able to tell whoever is using our library that no, you cannot call this function with a now argument, right? So something like that, it would be really nice and really helpful, in sort of like, debugging and things like that. So let me just, do the build. Okay, works like a charm, and up, and we get the information that we expect. Great job. So this shows that our memory safe wrappers are working, and our structures for the automaton, the alphabet, and I think the states are properly configured. They are properly wired. Thank you guys for watching, and I'll see you in the next video.